Welcome in. We're going to be going through week 4, module 4. So this deals with the integers, order of operations. So let's begin. The set of numbers consisting of the natural numbers, which are 0, and the integers are the 0 and the negatives of the natural numbers are the integers. So that is the counting numbers 1, 2, 3, 4, but also 0 and those negative values, -1, -2, -3, -4, so on. Positive integers is another way of describing the natural numbers. So that's these. Natural numbers are just those counting numbers without 0. Whole numbers are the natural numbers with 0, and then integers are all of those numbers combined with the negatives. The number line is a graph used to visualize a set of integers as well as sets of other numbers, and we can graph them as such. Right? And we can plot numbers, or we can graph particular numbers. So in this case, we're asked to graph a few numbers, -3, 4, and 0. Oh, excuse me. And 0. So we'll start with the number line, and then we just indicate the correct place for each of these values. So to graph, can't find my pin. There we go. To graph -3, I just locate -3 on the plot. And when I graph it, there it is. I'll just put in this case, a blue circle on that location. +4, I find the location for 4 and plot it. And of course, 0, I would find where 0 is on that line and plot it. We have symbols that we'll see. Those symbols are less than and greater than. And again, if I look at the number line, I have -4 and -1. Not the easiest. Oh, that's not helpful. Not the easiest to see, but I have these two values. -4 is to the left of -1, which means that -4 is less than -1. Or we can look at that the other way around. -1 is to the right of -4, which means -1 is greater than -4. Now, rather than writing out is less than and is greater than, we would write in symbols these less than. Right. -4 is less than -1, and -1 is greater than -4. You can think of it as the old allegory of the alligator trying to eat the larger value. It's always going to be open mouth towards the greater number. So if we were to try a few of these, right, we can say, is -4 less than or greater than 3? Well, 3 is the greater number, so -4 is less than -3 because it is to the left of it on a number line. Likewise, for the second one, B, -1 is to the right, right? We can, and if you're not sure, plot it out. There's -1 here, -2, -3, -4, -5. -5 is to the left of -1, which makes -1 the greater number. -5 is to the left of -2, and 0 is to the right of -3. So we use those symbols as such. Some of the times you'll see these symbols with a line under them, as you see here. That means that A on the left there could be less than, or it could be equal to B, right? So examples of that are listed here. These are true statements. 2 is less than or equal to 9, but also the statement 9 is less than or equal to 9 is true because 9 is equal to 9. So it could be a number less than the second, 9, or it could be the value that is 9 itself. Both make these true statements. This next one down here, B is greater than or equal to A, means that B could be greater than A, as is the case here. 9 is greater than 2, so that is true. But the next one down, 2 is equal to 2, and thus, therefore, that is true as well. Both 9 and 2 are greater than or equal to 2. The absolute value of a number, let's call it A here, which is denoted by this symbol, the A with 2 vertical bars on either side of it. The absolute value of this number is how far it is from 0 to that number, and we don't regard distance. So if it's to the left, I don't care. If it's to the right, I don't care. It's just how far away it is. So for example, the absolute value of 3 is 3 because it's 3 spaces away, but the absolute value of -3 is also 3 because it's 3 spaces away. So essentially, an absolute value throws away the negative if there is one, but the number is unchanged if there isn't one. So if we have to find the absolute value, we just did A. The absolute value of -3 is 3. The absolute value of 5 is 5 because it's 5 spaces away from 0. And the absolute value of 0 is 0. We can look at these on a graph. Can I erase what I've written? I don't think I can. Oh, I can. Eraser. That did not erase anything. Okay, that's not helpful. All right, I can't erase that. So, well, there we go. If I graphically look at it, once again, this -3 is 3 spaces away. Positive 5 is 5 spaces away. And then that absolute value of 0 is 0 because it is 0 spaces away from 0. To add integers, there's you have to be careful with the signs primarily. If I just have the easiest example is to just take 2 positive numbers. 2 plus 3 is 5. We have 2 apples. We add 3 more to it. There's 5 total, right? But if my values are both negative, so I have a negative number, -11, plus another negative, you can think of this maybe like a debt, right? I'm in debt $11 and I go in debt 15 more dollars. That debt is adding on to itself. It's in the negative direction because it's a debt, it's a loss to me. So I can think of it as, well, I had $11 I owed to somebody and I tacked on 15 more. And so that ends up being $26 that I owe to them. And it's negative then to indicate that it's a loss or an owe, something I owe. If the numbers are different from each other, like -13 plus 4, then those absolute values subtract from each other. So I'm going to take the difference between 13 and 4, excuse me, which is 9. And then I'll take the sign of the greater magnitude number. So this 13 is the bigger number. It's negative, and so my answer should be negative. So this 13, -13 plus 4, I find the difference, which is 9, and it's negative because the greater magnitude number was negative. On the other hand, if I have, say, 13 plus -6, right, this is just like a subtraction of 13 minus 6. I'll find the difference. The greater magnitude number, which is 13, is positive, so my answer remains positive. And here's a good little study tip here. If you can think of these as temperatures above or below 0 on the thermometer, this helps some people. If you think of the thermometer as a number line standing straight up, and -15 plus -15 is like 15 below 0, sorry, 11 below 0, and then 15 more below 0. So I'm going to add those two together, which is 26 below 0, which is a negative. And I'll let you read through the rest of those if you want, but let's, I think we'll move on. There's something called an additive inverse. An additive inverse has the same absolute value as each other, but they're on opposite sides of the number line. So for example, 18 and -18, they are additive inverses because they equal 0, and they're essentially the same number, but one is the opposite sign of each other. So -7 has an additive inverse that is +7. It's an additive inverse because they add together to be 0. So in general, an additive inverse of A is just negative A. If A was negative to begin with, then it's the positive of that value. When we subtract, right, we can think of subtraction as, if it's A minus B, it's just regular subtraction as we think of it. But we can also think of it as an addition, right? A minus B is the same as A plus negative B. So that's helpful because I can then change my signs for problems like part A. If 17 minus 11, if 17 minus negative 11, if that's what we're looking for, I can rewrite this as 17 plus the opposite of what's inside here, and the opposite, or the additive inverse of negative 11 is 11. And so essentially those two negatives, they kill each other. A lot of people like to think of it that way, and it turns into 17 plus 11. And then we have 28. Likewise, if I see this double negative here, negative 18 minus negative 5, I'll simplify that by calling this negative 18 plus the opposite of negative 5, or plus 5. Now they have different signs now, so I will take the 18 minus 5, and that is 13. But 18 was the larger magnitude number, and it started negative, so negative 18 plus 5 is then negative 13. I just keep that negative from the 18. And likewise with negative 18 minus 5, they're both negative, so I'll think about what 18 plus 5 is. Since they're both in the negative, their magnitudes will add together. 18 plus 5 is 23, and they were both negative, so my answer is that negative 18 minus 5 is negative 23. And if I multiply numbers together, right, we think of multiplication as simply repeated addition. And if I multiplied a positive number with a negative number, in this case, a positive 7 multiplied by a negative 5, a positive multiplied by a negative is going to be a negative. And so I end up with 7 times 5 is 35, but a positive times a negative is a negative. If I have a negative multiplied by a negative, then I end up with a positive. Right? So a negative multiplied by a negative is a positive. So 6 times 11 is 66. So negative 6 times negative 11 is 66 also. And then anything multiplied by 0 is 0. Any number that you end up with here multiplied by 0, you're going to end up with 0. If I have a bunch of multiplication, so I have in this top one, negative 2 multiplied by negative 3 multiplied by negative 5. Well, this first negative times this second negative turns this into a positive. And then I have one more negative. So in the end, these guys turn into a positive and then multiplied by a negative. So my answer in the end is going to be negative. Right? And you can always simply just count how many negatives you have. If you have an even number of negatives, they're going to cancel each other out. But if you have an odd number of negatives, then you'll end up with a negative in the end. And then I just multiply the values. 2 times 3 is 6, times 5 more is 30. We just decided by having an odd number of negatives, it would be negative. So I end up with negative 30. If one of these numbers changes, now I have an even number of negatives. The negative on the 2 and the negative on the 5 will cancel each other to be positive, and so I have positives times positives. That ends up being positive. And so again, I take 2 times 3, which is 6, and multiply it by 5, and I get 30. And it's positive because I have an even number of negatives. In exponential notation, the exponents just indicate repeated multiplication. So for example, 2 to the 4th means 2 multiplied by 2 multiplied by 2 again, multiplied by 2 again, multiplied by 2 again. So if I wanted to evaluate, I can rewrite this out, and then I take 2 times 2, which is 4, times the next 2, which is 8, times the next 2 gives me 16. For example, a negative 6 squared. That negative is inside the parentheses, so that means I have negative 6 being multiplied by negative 6. And a negative times a negative is a positive, and then 6 times 6 is 36, so I have 36. Now there's a difference between A and B. B is just negative of 6 squared. That negative has nothing to do with the second power here, or the square. This means it's a negative of 6 times 6. That 2, that squared, is only acting on the 6. It's not acting on the negative because it's not in parentheses. So this is still negative in the end because it's just a negative of whatever that square is, 6 times 6, which is 36. But when we get to C, that negative is back inside the parentheses. And so I have negative 5 that gets cubed with negative 1, 2, and 3 of them. So a negative times a negative times a negative is negative. So I end up with a negative value. 5 times 5 is 25, times that third 5 gives me 125. Try the next one, D. I will give the answer. It is positive, and it's 16. All right, if I divide an integer by another non-zero integer, then I get a quotient. Right? And that's essentially what a quotient means, is the division of two integers, as long as the denominator integer, the bottom integer, is not a 0. We can write it in two ways, a divided by b, or this a slash b notation. So we can write it as division this way, or as a fraction. And really it just means that we're subtracting repeatedly. But if I have something like, say, 10 divided by 5, it says, it's asking how many times can I subtract 5 from 10 before I get to 0. If I subtract it one time, I am left with 5, and I subtract 5 a second time, and I get to 0, so my answer is 2. I can take 5 out of 10 twice. Now, if I get larger values, say 80 divided by 4, I can take 4 from 80 20 times. But if I have a negative in there, right? If I take a positive divided by a negative, that will end up being a negative value. Or a negative divided by a positive value is going to be a negative, right? So if they're not like signs, you're going to end up with a negative at the end. But if they are like signs, as is here, a positive divided by a positive will be a positive, and a negative divided by a negative will be a positive again. Right? If 0 is in my numerator, this will always be 0, no matter what my denominator is, right? Because I can't take anything from 0 before I get to 0. But if I have 0 in the denominator, then I can't do anything with that. We call this undefined. If I try to use the repeated subtraction, that's like saying I'm going to take this negative 8 and subtract 0 and see how many times it takes me to get to 0. But every time I subtract a 0, I never move, I never get closer to 0, and therefore I can't define the number of times that I would have to take 0 from 8, or negative 8 in this case, before I get to 0. Right? So it's undefined. Order of operations, a lot of people like to call this PEMDAS. Some people don't like that word, or that grouping of letters. But essentially, let me get a clean sheet here. PEMDAS is, P is for the parentheses, or any grouping symbol. E is for exponents. And then M and D, we have to be careful with these because this is the order that you should look at these. You should look inside any parentheses first, and then you should look at any exponent second. But with multiplication and division, they have the same priority. So I'm going to write multiplication and division on the same row. That's my M and my D. Meaning if when I come down to this line and I'm looking at the multiplication and division, I go from left to right and I do whichever one of these multiplication or division comes first. I don't do all the multiplication and then go back through and do the division. I go through one time and I do multiplication as I come to it and I do division as I come to it. So if there's a divide before multiply, I do that divide first. And then the addition and subtraction, they have the same priority as well. So again, I go through left to right. If there's a subtraction before there's an addition, I'll do that subtraction. If there's the addition before the subtraction, I'll do it, right? Well, let's take a look at this problem that I've just kind of written over. See if I can erase this stuff. Yes. Sort of. 8 days later. There we go. And let's look at this. So as I go through, there's no grouping symbols, all right? There's no parentheses, so I'm okay with that. And P is good. So I go through and do my exponents. And I see there's a couple of spots where I have exponents. 6 squared, that's 36. This 2 squared, that's going to be 4, right? So I'll just rewrite this problem, having done just those two operations with the exponents. My exponents are now done. I'll move on to multiplication and division. Again, I go left to right. The very first one of these I come to is a division, right? It's multiplication or division, whichever's first, left to right. So I do it. 24 divided by 4 is 6. And I'm going to rewrite everything else and leave it all the same. I'll go back from left to right and look for any multiplication or division again, and I do see one. I've got a 6 times 3, which is 18. And so again, I do that, and I leave everything else the same. There's no more multiplication or division. I'm good there, so I move to addition and subtraction. And I go left to right. Again, whichever one comes first, addition or subtraction. So I've got 36 minus 18. That's my first operation. I do it. 36 minus 18 is 18. And then I go back through to look again. Is there any more addition or subtraction? There is. I have 18 plus 1, and that is 19. Again, make sure that you're good on the order of operations. There are some that can be tricky, but yeah, let me know if you have any questions. And thanks, and bye.